Hey, definition of an infinite series. It's a series that goes on for infinity.
What?
Sometimes it's useful to look at partial sums, adding a finite number of terms together of an infinite series. And we're going to do that in just a second, because when I first saw the word partial sums, I was like, what are they
That
talking
sounds
about?
like calculus.
Yeah, it kind of does, actually. So just to go over this definition, we've been hinting at it, and it's kind of like what we talked about last time with sequences, but a series is said to converge if its sequence of partial sums approach a number. So in other words, as you add more and more terms together, the sum should get closer and closer to a certain number.
So go back to the previous two slides when we looked at the geometric sequences of those two problems.
Right.
And we added an infinite, we added a finite number of terms, just like 100 in each case.
Right, and
But
we
the
were getting really
calculator-
close to a certain number.
And the error on the calculator told us that the answer was 4
Right.
on one of them, and gave
And
us a
6 on
specific
the
6 on
other.
the, and it gave
Yeah.
us specifically gave us those numbers.
Yeah. Okay. So a series is said to diverge if, as terms are added, the sum approaches infinity or alternates between two numbers. And when we talk about convergence, like we mentioned, it has to be geometric, and we're actually gonna, I think, in a second, see a specific thing that has to happen in order for it to be geometric, which you might actually be able to guess if
Right.
you haven't already.
Just like the books, everybody dies at the end. Okay, divergent.
Please don't listen to him. Example 5, looking at limits of partial sums. So for each series, we're going to find the first 5 terms in the sequence of partial sums. So the first thing you do is just take the first term, and that's your first partial sum. So you're taking the sum of the first one term. Okay, and then you say, okay, what about the sum of the first two terms? So if I add 0.1 and 0.01 together, I get...
0.11.
Okay, so
What are you doing? Why are you taking over?
We're making a sequence of...
Did you not like the way
No, I
that I
didn't.
wrote that?
Okay, so the first partial sum is 0.1. The second one, we're adding the first two terms together, so it would be 0.11. We're making
How did your handwriting get so much better?
I don't know. We're making a sequence of partial sums. So
So
the
then
first one is 0.1. The second one is 0.11.
Can I talk? The next one's going to be 0.111.
Okay.
Thank you. Don't make me ruin the books.
Okay. Next.
0.1111.
Okay. And then...
0.11111.
And that's it. That's all we need. First 5 terms in the sequence of partial sums. So what do we think it is converging to?
I think it's converging to 0.1 repeating.
I agree. So it converges to 0.1 repeating. So
We could get that as a fraction too, could we not?
probably, but we're actually going to do that in a second. I think it'd be like 1/9
okay.
though.
I think you're right. I'll double
You
check.
wanna try
real
that?
quick, yeah.
Okay, so part B. So the first partial sum is just 10. The second partial sum is 10 plus 20. So the sum of the first two terms, so that's 30. The next one is 10 plus 20 plus 30, which gives us 60. And then 10 plus 20 plus 30 plus 40, so that's 100. And then it doesn't give us the next term, but that would be 50, so that would be 150. So this one is diverging because
It's getting
we're
bigger all the time.
Yeah, we're getting closer and closer to infinity. And last, let's try C. Ooh. Okay, so the sum of the first term is 1. The sum of the first two terms, 1 minus 1, 0. The sum of the first 3 terms,
-1,
no.
0,
No.
1.
1 minus 1 is 0, plus 1 is 1.
That's what I said.
Okay, and the first 4 terms,
-1. I
0.
know. Dang it.
and then the next term after -1 would be a positive 1, so that would make it be 1 again. So you might be like, oh, it converges to 0 sometimes and it converges to 1 sometimes. Well, it can't do that. It
That
can't
doesn't
converge
converge.
to two things.
It's got to actually approach one set specific number
Right, so that diverges.
where everybody dies in the end. So on this that would be an oscillating situation.
Yes, this
by
is
the way,
oscillating when it
vocabulary.
goes back and forth. And
Yes.
so it all depends on where you end your sum as to what value you get at the end. You
Right.
can't be like, oh, until it gets to infinity, this is what the answer is.
Right.